All right, here are answers to the review for the quiz. So first one, solve each systems by graphing. So I'm going to graph y equals 7x minus 3. So I have a y-intercept of -3, and the slope is 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 over 1. So there's my first line. When you graph a line, you see it went through that top point well, but not the bottom. Press select and move the bottom of that line over a little bit. There we go. Okay, let's do the other one. I'll do this one in red. Y equals x plus 3. So I have a y-intercept of 3, and the slope is 1. So up 1 over 1. So I can already see where I'm going to cross, even though when I moved that top line, it looks like I actually, there, that's really where I want that top line to be. But here's my second line. When you graph these, even though you see where the solution is going to be, I want to see both graphs on there so that I know that you know what you're doing. So the solution here is over 1, up 4. So 1 on the x, 4 on the y. Again, give that answer as a coordinate, not as a x equals 1 or y equals 4. All right, over here, let's graph x plus 4. So y-intercept of 4, the slope is 1. So up 1 over 1, that takes me off the graph. So I could also go down and to the left if I want. Let's put a line. And then y equals 3. So we have to remember what that looks like. Y equals 3 is a horizontal line at 3. So I have a line like that. Point of intersection is there. So my answer is -1, 3. Okay, there's graphing. Doesn't really get much more complicated. I mean, maybe I would have put a negative slope. I probably should have on this, but I didn't. Substitution. So I've got one of the equations is already solved for one of the variables. So I'm going to plug that into the other one. So I'll have -6x plus 3 times 2x plus 7 equals 5. I'm going to distribute. So -6x plus 6x plus 21 equals 5. Or something weird's going to happen here. This is going to cancel. I'm going to be left with 21 equals 5. Think back. What happens when our variables all go away and we're left with something that's not true? That means this has no solution. What does it mean those lines are if I graphed them? If I graphed these lines, it means they have the same slope. If I were to put this equation into y equals mx plus b form, I would add 6x to both sides and divide by 3. These would both end up having a slope of 2. So these are parallel lines. They're never going to touch. They have the same slope, so therefore they're not going to have any solution because there's nowhere that they cross. Okay, number 4 is substitution. So let's plug in that into here. Be careful of our negatives. -7x minus -6 equals 6. See how that happened? This is a minus, but I'm plugging in a negative. That means I have minus -6. It turns into plus 6. So -7x, plus 6 equals 6. Let me go ahead and subtract 6 from both sides. I get 7x equals 0. That's okay. Divide by 7. I get x equals 0. That's my final answer for x. It's okay. Nothing wrong with that. Well, what's y going to equal? Well, take 0 and plug it in for x and solve for y. Or realize this equation's already solved for y. That is my y. X is going to be 0 and y is going to be -6. Those are my two solutions. If you weren't sure, you could plug 0 in for this top equation and solve for y that way. Plug 0 in, you end up getting also y equals -6. All right, number 5, elimination. So for the first one, we're totally set up. Our y's are perfect. I have a +3 in front of this one and a -3 in front of this one. So my magical adding of the two equations is going to work perfectly. So I'm going to add the two equations together. Remember that I am always adding the two equations together. -2x plus 3x is x. I get 0 here. 4 plus -6 is -2. Boom, I already have my answer for x. Plug that back into either equation. I'm going to plug it in here. So I'm going to have, instead of 3x minus 3y equals negative 6, I'm going to have 3 times negative 2 minus 3y equals negative 6. So negative 6 minus 3y equals negative 6. Oh my gosh, do I get 0 again? Plus 6 plus 6. I do. Negative 3y equals 0. Divide, and I get, whoops, y equals 0. That's odd. I didn't really mean to do that, but whatever. So again, I could leave that answer as a coordinate, or I could make it just x equals the negative 2 and y equals 0. Okay, over here I have a lot more work to do. So I don't have the same number in front of the x's or in front of the y's, but I do have opposite signs, so that is helpful. I'm going to take my top equation, and I'm going to multiply everything by 2. I'm going to do that so my x's have the same coefficient, different signs. If you instead wanted to multiply the bottom equation by 7, you could have done that, and then your y's would have had the same number and different signs. I'm picking 2 just because it's literally a smaller number to multiply by. So I'm going to multiply this by 2. I'm going to rewrite everything. So when I multiply by 2, I'm going to have negative 12x plus 14y equals 48. Don't forget, multiplying 2 by everything. The other one doesn't change. Put this together. Negative 12 plus negative 12. I'm adding here. So negative 24x. Wait, what the heck did I just do? Sorry. This was not. I was going to say something was wrong there. Sorry about that. This 12 was never negative. I don't know why I made it so. So put these together. This is 0. And I have 13y equals, oh my gosh, I can barely see what I wrote, 78. Is that right? Divide both sides by 13 and hope that that goes evenly, or I messed up the problem. Let's see. 78 divided by 13 is 6. Awesome. So y equals 6. There's part of my answer. I'm going to go back and plug that into one of the original equations. It doesn't matter which one. So I'm going to plug it into this. It's just a little less work because the y doesn't have a coefficient other than that negative. So I'm going to have 12x minus y, which is 6, equals 30. So 12x equals 36. When I add 6 to both sides, x equals 3. So there's my answer. X is 3 and y is 6. Those should have been fairly simple. Hopefully that makes you feel like you're good to go and ready for the quiz on Monday.